Hello problem solvers. So here is an inequality problem which I saw from another math channel, Cybermath, SYBERMATH. Okay, Cyber, I hope I correctly pronounce his name. So he used, so actually please try first before I discuss his method and my method. Okay, please try first. Okay, so he used a trigonometric substitution to solve this inequality, which is okay, because one of the techniques when proving inequality is to use a trig sub. But there is an easier substitution, and I want to show you that. So previously I was showing you how to do a symmetric polynomial problem. And if you just look at the left hand side of this inequality, it is symmetric. So that suggests us to try to apply elementary symmetric polynomials, and actually it works out. So let me show you. Okay, if you don't know what is elementary symmetric polynomials, you can watch the video that I discuss how to solve x, y, z equals 1, etc. the problem. Okay, you can watch that video where I explain the basics about symmetric polynomial. So let's just use it here. So that is a hint. If you want to try it yourself, please go ahead before watching my solution. Okay, so we only have two variables, and so first of all, I said that this is symmetric, but well, the top is symmetric. But what about the bottom? The bottom is also symmetric, but we need to express them in terms of elementary symmetric polynomials. Okay, remember we have, for two variables, these are the elementary symmetric polynomials. So obviously we can express that in terms of s and t. But what about the denominator? So if you expand the denominator, you get, okay, so this I can make it t squared. But what about this? Well, remember in that video I told you that any symmetric polynomial is always expressible uniquely as the elementary symmetric polynomials. So you can express that in terms of s and t, and here is how. So x squared plus y squared is just x plus y squared minus 2xy, right? And so that is my s squared, that is 2t. Okay, so let's just show you that this is expressible in terms of s and t. Okay, so let's try to solve it. So first of all, we have this absolute value sign here, and obviously the bottom is always positive, so the absolute value only applies to the top. So let me just let's just clear the denominator first. Okay, And now let's use S and T. So the right hand side would be 1 plus t squared plus s squared plus 2t. And you see this is s times 1 minus t. And if you just look at the t here, you can also combine it into 1 minus t or t minus 1. This is just 1 minus t squared. Okay, at this moment, I hope you see the answer. Okay, this is just a straightforward AMGM inequality. Okay, but what about the absolute value sign? Well, it doesn't matter. This is just equal to, let's just give everyone the absolute value, and here also, right? They are the same, right? S squared is like square the absolute value of s, right? They are the same. Okay, this is equal to this, this is equal to this, and now we just apply AMGM because absolute value of 1 minus t and absolute value of SE are non-negative. So AMGM gives us this inequality. Okay, AMGM says a squared plus b squared bigger than 2ab. Right? So in other words, basically if you want, you can just complete things square. Where you can actually put this to the right hand side and you can complete square. Okay, so that solves the inequality. Traditionally, after we solve an inequality problem, we will look at the equality conditions. When will this be equal? Well, I said traditionally. In this case, I won't dive into that part because it's quite complicated. It's just complicated. It's not hard. It's complicated. It's very complicated. You have to a graphical method will work. Will just convince you. You have those are the only solutions. I think there are about 8. If I'm not mistaken, there should be 8. At least 8, let's say. But yeah, the key thing I hope you learn is that this is symmetric. So you can use elementary symmetric polynomials to greatly simplify, right? This complicated looking is just AMGM applied to 1 minus t and s. That's what I want to show you. And finally, let me give this a difficulty rating. So I would say this is an easy National Mathematical Olympiad problem. So I would give it a 4 out of 9. And the character for this level would be Neji. Okay, so thank you for watching.